All right, so today we're focusing on systems of equations and solving systems graphically. So you may remember in Algebra 1 you solved systems graphically. You also solved using substitution and elimination. So some of these terms that we're talking about might seem familiar to you. So a system of equations is just two or more equations that have the same variables. And one of the ways that you can solve them is to graph. So that's what we're going to focus on today. And the solution for a system is represented by the point xy of intersection. So your solution is the point of your intersection. Okay, so we're going to have three different types of graphs. We're going to draw a model of each type. So if you just want to do a quick XY axis for each one of these, and then we'll talk about each type of graph. Okay, so the first situation you can have is you can have two lines that intersect each other. I'm going to color code them. Okay, so they're going to intersect in one point here. Okay, so the type of graph, this is the type of graph that intersects at one point xy. Okay, the other type of graph is the same line, which means when you graph it, one line goes right on top of the other one. Sometimes to just show that, I'll use like a highlighter just to make it stand out. Okay, so that's when you have the same line. Okay, and then the last type, I bet you know the name once you see the picture. These lines are, yes, parallel lines. Okay, now the equations, when you have your equations, we know that we want them in the form y equals mx plus b. Okay, if they intersect at one point, we know that the slopes are different. Okay, so you're going to have different slopes. If it's the same line though, then yeah, you're going to have the same slope and you're also going to have the same what? Yep, same slope and y-intercept. Okay, and then if they're parallel, do you guys remember from geometry? Yep, same slope and different y-intercept. Very nice. Okay, so then that's going to lead to the type of solution that you're going to have. So if it intersects at one point, there's only one solution. It's that point. But if it's the same line, how many points are there on a line? Infinite. So there's infinitely many solutions. And then for parallel lines, there's no solution. They don't meet. There's never a point where they meet, so there is no solution. Okay, now the last box, the classification, this might be something new for you. So if there is a solution, we say that the system is consistent. So that means if there's one solution, it's consistent. Okay, and if there are infinitely many, it's consistent. But if there's no solution, it is inconsistent. Okay, and that's how, bless you, and that's how I remember that part. So if it has a solution, consistent. If there's no solution, it's inconsistent. There's one more part though. Okay, the other part is if there is a solution, okay, one of them is independent, one of them is dependent. Okay, so what do we think? Is something that's independent, would you associate that with the word one or infinite? That's independent. That one. Independent, it could stand on its own, right? Think Beyonce's song, Independent Women. She doesn't need a man. She's on her own. Just one. Okay? So, consistent and dependent. You guys are laughing now, but on your test, you're going to remember that. One of these solutions is I remember. Okay, so what we're going to have to do is we're going to have to classify solutions as consistent or independent or dependent or inconsistent. Okay, so if there's a solution consistent, if there's one independent, many dependent. Okay, that's because there's so many, it depends on what values you have. One depends on the other. What about? Right, so if it's inconsistent, we can't classify it as independent or dependent. It's neither because there's no solution. Yep. All right, so in example one, they are asking for several things. First is, it says determine the number of solutions, then state whether the system is consistent or inconsistent, and whether it's independent or dependent. So when we're doing this, we are going to first make sure that the equations are in the form y equals mx plus b, and then we're going to compare the slope and the y-intercept. Because based on those two things, we can tell what our solutions are. Okay, so for A, you already have those in the proper form. Y equals mx plus b, y equals mx plus b. So we're just going to look at the slope. Are the slopes the same or different? Same. Y-intercept the same or different? Different. Okay, so we just have to find, and we can use our chart, we can just find the one that has the same slope and different y-intercept. Which one would that be? So same slope and different y-intercept are parallel lines, which means there's no solution. So it's asking us how many solutions are no solution? 0. So you just put 0, and then I just use a semicolon because we have to do the consistent or inconsistent. So if there's 0, it's going to be inconsistent. And remember, if it's inconsistent, then you don't have to identify independent or dependent. Doesn't exist in that case. Okay, so what I want you to do for parts B and C, if I'm not fast enough for you, okay, is I want you to put each of these in the form y equals mx plus b. So this is not in the proper form. I want you to show your steps. And do the same thing with 2x plus y equals 12. Okay, so I want you to put those in the proper form and then classify if consistent or inconsistent, dependent or independent. Okay, so when you're putting this in slope-intercept form, your first step was subtracting over the 7x. Make sure you drop down your negative with that. and then you're dividing by -3. Did you guys have enough time to finish that one? Okay. So a negative over a negative is a positive. Positive over a negative is going to be a negative. Okay, so this is your y equals mx plus b form. For here, we're just going to subtract the 2x. So -2x plus 12. Okay, and then we compare the slopes. So the slopes are obviously not the same. If they're different slopes, there's only one type of situation where you have different slopes. And what situation is that? Where you have how many solutions? Yep, it's the intersecting. Yep, so they intersect in one point. There's one solution. If there's one solution, it's consistent because every time it's consistent, it has a solution. And one is independent, can stand on its own. All right, and then we're going to do something similar for part C. So we have to make sure that we're putting these in the proper form. Okay, so in order to get y by itself, I'm going to divide by -10. When I do that, I have to reduce. You're always going to be reducing your fractions. So 2 goes into both, so this would be -2 over 5x. Divide by 2, divide by 2. This is going to be negative, a positive over a negative, so divide by 2, divide by 2. And then if you have your y equals on this side, it's fine. If you just leave it like that, that's okay. Okay, so that's your y equals your mx plus b.
Would I be able to, like, for example, normally I would write y equals 12 minus 2x. Would that be okay?
You really should write it with the mx first.
Okay.
And then we're going to divide by 5, and in this case, you just have to pay attention to your signs. You aren't going to have to reduce. And then once you compare, you can see you have the same value for the slope, the m, the same value for the b. Okay, so if you have the same slope and y-intercept, or the m and the b, that means they overlap each other, so there's infinitely many solutions. So infinitely many is the number of solutions. Is it consistent or inconsistent? Consistent. Anytime there's a solution, it's consistent. And then is it dependent or independent? Dependent. So when there's many, it's dependent. It's because there's so many, it depends on what your value is. Okay, your x value determines your y value. All right, so now examples 2 and 3 say to solve by graphing. Now, we've already talked about different ways you can figure out how many solutions there are, but when it says to solve by graphing, you need to make sure that you graph those. So this time you are actually solving. Here we didn't have to solve. Okay, so when you're doing this, you're going to find the actual values if you do have a point, or you'll have no solution, or you'll have infinitely many. So just like we did above, when we're graphing, we absolutely want to make sure they're in this form, because when we're graphing, we start at the y-intercept, and then we use our slope. So we have y plus 3x equals 3. So I'm just going to move the 3x over, so I have to subtract it. Okay, and then let's graph this. So when you are graphing, make sure that you go a couple points above and a couple points below your y-intercept. So this is a positive 3, so I'm going to start at 3. And your slope, if it's a whole number, it's just over 1. So if you go down 1, 2, 3, you're going to go to the right 1. 1, 2, 3, right 1. 1, 2, 3, right 1. And then let's go in the opposite direction as well. So I'm going to go up, 1, 2, 3, right 1, 1, 2, 3, right 1. And then use your straight edge. Okay, we don't want to get sloppy with these because that can affect our outcome. Okay, and then for the second line, we have 6x plus 1 equals negative 2y. So to get the y by itself, divide by negative 2. Can you guys simplify that and then wrap it? Okay, so when you divide by 2, you should have negative 3x minus 1/2. Okay, and then it's okay that it's a fraction. That just means we're going to start at negative 1/2. And then when we go down 3, 1, 2, 3, we're just going to be at the halfway mark every time. Then go up, 1, 2, 3, over, 1, 2, 3, over. Okay, and then again, make sure you're using your straight edge. If these lines are parallel, which they are, which you can tell because their slopes are the same, okay, your graph should not be intersecting anywhere. Like, don't get lazy down here. Okay, and if they're parallel lines, they're never going to meet. So what's your solution? No solution. Okay, so this is your final answer there. Okay, and then for part B, you have y minus 2x equals 4. So we're going to get that in y equals mx plus b form and graph it. And then this one's already in the proper form, so we're all set. Okay, so I'm going to start at 4. If it's positive 2, I'm going up and then right. And then when I go the opposite way, I go to the left. Okay, I'm going to use my straight edge to connect. Okay, and then I'm going to start at negative 6. Again, just make sure if it's positive, your graph is going up from left to right. If it's negative, it should be going down. So this is negative 3. So it's like a negative 3 over 1. So if you go down, 1, 2, 3, you go to the right. 1, 2, 3, up, go to the left. 1, 2, 3, and then look, you can see where they meet. Right? Because your point already overlapped another point. And really, once that happens, you know that you found your solution. Okay, your solution is where they intersect each other. Okay, so they intersect right here. So that point is what? Negative 2, 0. So remember the x goes first, so negative 2, up 0. That is your solution. All right, and then the last one. Okay, will you guys put those in the form y equals mx plus b and then graph them? So see if you can do it without me. Okay, this is another situation where we got to know how to reduce. So if you have a negative over a negative, it's a positive. Negative over a negative, it's a positive. And then what's a number that goes into both 6 and 4? 2. So divide by 2, divide by 2. Okay, for this one, again, you're always trying to get the y by itself. Okay, so you have 1/2 x, and then 3 goes into both of those. And so the situation we have here is the lines are the same. Do we know what the solution is going to be even before we graph it? Definitely matters. Okay, so we still have to graph it because it says to graph it. This is how you need to solve it. So 3 over 2 is the same thing as 1/2. So we're going to start there. We're going to go up 1 over 2. Up 1 over 2. Up 1 over 2. Back 1 over 2. Back 1 over 2. Okay, and then we're going to use our straight edge. And then to show that I have both lines on there, do you guys remember what I said I did? Yeah, I just take a highlighter and go right over it. Show those 2 lines. Okay, and then anytime it's the same line, your final answer is infinitely many solutions. All right, so now we're going to take our knowledge about solving with graphing and we're going to apply it to a real world situation. And we have Pedro and Bella that are reading the same book for their English class, their language arts class. It says on Saturday, Pedro is going to start at page 20 and he reads an average rate of 25 pages per hour. And then we have Bella, so I'm going to use a different color for Bella. Bella starts reading the same time, but she starts at page 60 and reads at an average rate of 18 pages per hour. Okay, so part A says write equations for the total number of pages each student reads on Saturday. Okay, so these are both going to be linear equations. I want you to see if you can write a linear equation for Pedro and for Bella. So think about some story problems that we've done in the past to help you. Okay, so in the past we talked about the starting value. The starting value is what in your equation? Yes, your y-intercept. Okay, and then what else do they give us that is going to be part of our equation? Well, our variable is going to be what? Yeah, the slope is going to be the rate. Our variable is going to be x. So it's going to be y equals, okay, the rate is your slope, so 25x. And he starts at 20 plus 20. How did we do? How did you guys do? So this is your rate. This is where you start. Okay, if you had trouble doing that without me, but now you've seen this, go ahead and try it for Bella. Okay, so it's very similar. What's Bella's rate? 18, and it starts at 60. So 18x plus 60. Okay, it's the same situation. The rate and then your starting point is your y-intercept. Okay, so then for B, we're going to graph the equations on the same coordinate plane. Okay, so we're going to graph those. We're going to examine the graph to estimate after how many hours of reading the students will be on the same page. So we're going to graph and then we're going to estimate. Okay, and I guess here I'll highlight right equations because that's what we did. All right, so when you are graphing and you have a story problem like this with some larger numbers, please understand that your graph may not look exactly like somebody else's. It is an estimation. And then before I start my graph, I make a table because it is very helpful to know what my values are going to be. When you are making a table, you can plug in anything you want for the x value. So these are our two equations, right? Okay, so anytime you're making a graph, make a table. Okay, that's going to give you a good set of points to graph. Now, in a story problem, you're dealing with, this is hours and this is pages, right? So both of these are going to be what type of values? Like when I'm creating my graph, if it's hours, I'm only going to have what kind of hours? Positive. So when I'm setting up my graph, I'm not going to do my units yet because I want to use my table to help me with that. But I know my x is going to represent the amount of hours, and I know my y is going to represent the amount of pages. Okay, so where am I going to start on the x-axis? 0. You're going to start at 0. So at 0, Pedro has read 20 pages. At the start, Bella has read 60. Okay? When you are doing this at home on your own, you can pick whatever you want. This is what I do not recommend. I do not recommend going 1, 2, 3, 4, 5, because that's only going to give you a small picture of what's happening here. Okay, so I'm going to go up a few. The way I determine is I just do things I can multiply in my head easily. Like I know that 25 times 4 is what? 100. So I said, okay, I'm going to pick 4 then. So 25 times 4 is 100. 100 plus 20 is 120. Okay, and then again, you can pick whatever you want. After that, I said, oh, I want to see what happens at 8. Because if 4 times 25 is 100, what's 8 times 25? 200. Yeah, so 200 plus 20, 220, right? So that was just something I could do easily in my head. And then I said, oh, 10 usually works out pretty nicely when I multiply by 10, because 10 times 25 is 250, 250 plus 20, 270, okay? And then I said, all right, let's catch Bella up and let's see if we have some overlap there. And then I just chose to do the same values. You don't even have to do the same values. If you're like, oh, I don't like those numbers, I want to do 0, 5, 10, 15, you could absolutely do that, okay? So at 4, I have 18. Do we know what 18 times 2 is? 36. So what's 36 plus 36? No. What's 36 and 36? 72. So then if I can do 72 plus 60, yep, then I can put that in there. And then I use the same logic that I did before. Do you guys remember here how I said this was 100 and then 8 was double it? So if you double it, it was 200. So if this is 8, I just have to double 72. What's 72 and 72? Yep. And then we're going to add 60 to that. I know some of you are processing it with me. That's okay. I'm trying to go slow enough. Okay, so again, I said, oh, if this is double, just double what you had before. So at 72, just double 72, and then add your 60 to it, and that's going to be 204. And then 10 is always fun. 10 times anything, just add the 0. 180 plus 60, 240. All right, so what we're going to do now is we're going to plot these points, okay, and then we're going to see where they intersect, okay. So I use 0, 4, 8, 10. So if I count these, I know I have 14. I've counted them several times today. So you can choose what your scale is by. Did I make a mistake? Oh, that's probably right. I probably just stopped early. And then I just label every other one. I feel like that helps me. Yeah, the 15 is that one. I just labeled to 14. Okay, and then based on my Y's, this goes up to 270, that's 240. So I probably want to get to around 300. So if I want to get to around 300, okay, and we have 15 here, if I went by 10s, that would only be 150. So let's go by 20s, that would get me to 300. Again, when you have your own graph paper, you can really go by whatever you want. So 20, 40, 60, 80, 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, 260, 280, 300. Okay, and you can label every other one, you can label every other three, just have some labels on there. I like to label it because when I'm graphing these points, I like to use those for reference. Okay, so make sure that you are labeling some of those. And then I'm going to do this with a pencil. I recommend you do that too. So when you plot 0, 20, that one's pretty nice. And then we have 4, 120. That one's actually really nice too. And then you have 8, 220. And then you have 10, 270. So if this is 280 and that's 260, 270 is right in between there. And then we're going to use our straight edge to connect the points. And I recommend doing one line at a time so you know what points you're connecting. Okay, and there is a margin of error that occurs when you're doing this by hand. So that's why I said it's okay if yours isn't the exact same as somebody next to you. Okay, and then we'll graph the second line. So at 0, 60, your first one, and then you have 4, 132. So if this is 120, this is 130. So 132 is really close. Oh, sorry, this is 140. So I went by 20s. Right, so if this is 140, 130 is halfway in between. And so it's really close to that halfway mark. Okay, and then at 8, I'm at 204. So here's 180, here's 200, so it's really close to that. And then at 10, I'm at 240. So here's 220, so this would be 240. Oh, this is my 240. It's like, that seems really high, and it is. So just double check your points. I just double checked mine. I put mine at the wrong thing, but I could tell because when I went to connect the points, they weren't all in the same line. Okay, and then you're looking for the point where they intersect each other. Okay, so that point of intersection, just going to put a little dot. So mine looks like it is right here. Okay, and then to find where it is, it says after how many hours of reading. So hours is the x value, so I have to find the x value. So I'm just going to bring this point straight down. Oh, and I usually like to use my straight edge for that because I don't always trust my straight down abilities. Okay, so let's approximate what the hours are. So I went by ones here. So this was 4, this was 5. It looks like it's in between 5 and 6. So I'm going to estimate as 5.5 hours. Okay, depending on what your graph looks like, maybe yours looks like it's closer to 6. So you would say 5.7. That's okay. Maybe yours is a little bit closer to 5, just depending on where you estimate it. So you do 5.2, that's okay. All right, so this is an estimation. and there are going to be some fluctuations, okay? So for C, it's asking you to check your estimate. So this is a way for you to determine if your estimate is reasonable. Okay, so you have to justify that with reasoning. When they ask you to check your estimate, what that means is you are going to plug in the value that you found into each equation. So remember we had an equation for Pedro and for Bella? Pedro was y equals 25x plus 20, and Bella was 18x plus 60. All we have to do is plug in our estimate. So we had x was about 5.5. We're just going to plug that in. We're going to use our calculator to do so. It's a great day, isn't it? Okay, and then I want you guys to write what you get with that. Okay, and if you don't have your graphing calculator with you today, but you have a scientific one, you'll want that too for the next thing. All right, and what do we get for Pedro? What is our number when you get there? What and a half? What did you get?
I got
5.5.
Yeah, 5.5. You just plug in 5.5 here? Yeah, 157.5. Okay, so 25 times 5.5 plus 20. Oh, Lord. Put in 25 twice. All right, what do you have for the next one? Oh, okay, good. All right, so you have to explain how reasonable your estimate is. So do we think this is reasonable? Yeah, why? Yeah, so that's exactly what we're going to say. So my estimate is very reasonable. Because at 5.5 hours, Pedro and Bella are 1.5 pages apart. Okay, so use the evidence that you found here. So this is your check. Okay, the check is plugging it back in, and then you're using that evidence from your check to justify whether it's reasonable or not. Okay, if they're 10 pages apart, then that's not going to be as reasonable. Okay? All right, so the next thing I'm going to do is teach you how to use a graphing calculator to graph. Will you just raise your hand if you've graphed equations on a graphing calculator before? Okay. So when you are using a graphing calculator, we are going to use that with example 5 and example 6. You can use this to solve systems. Okay, and then notice it says you're going to round to the nearest hundredth. So that's what we're going to be doing for both of these. In 6, we're going to be using a graphing calculator. This one said to solve the system. Here we're going to solve the equation. Okay, and then again, we're rounding to the nearest hundredth. So these are going to be very similar to each other. And I'm going to have you write down your steps. So if you don't have your graphing calculator today, you can still follow these steps. Your first step is always to put it into y equals mx plus b form. You need it in this form in order to enter it into your graphing calculator. In your graphing calculator, you are going to see a button that says y equals. Anytime you have to push a button, I try to put it as a button on there, so copy this down with me. Okay, and after you hit y equals, you're going to plug in equations to y1 equals and y2 equals. Okay, then you are going to graph. So after you plug them in, you're going to hit the graph button. When you graph, there are some times where you are not going to be able to see what you need to see. And when that happens, we are going to adjust the viewing window. Okay, and then we're going to use a feature on the calculator. To get to this feature, you have to press the second button and then the trace button. You're going to press the second button and then the trace button. And then you can arrow down to the feature called intersection. So arrow down to the feature called intersection. Because this is asking you to solve the system, your solution for the system is going to be an XY point. Okay, unless it's I said no solution are infinitely many, but for these they won't be, it'll be a solution. All right, so we're going to start by putting these in the proper form. So you have 2.5x minus 1.9y equals 24. Okay, so if we want that in the form y equals mx plus b, we're going to move our x term over. And we are going to be dividing by decimals with our calculator. And when you divide, you're going to have to round properly. Okay, so when you are dividing on your calculator, you have negative 2.5 divided by negative 1.9. Okay, and so I'm going to round to 1.32. You always look at the third number. 5 or above goes up, rounds that up. Okay, so if you have something that's 5 or above, you're going to round up. And then if you have the third number is 4 or below, it stays the same. Okay, so that's going to be 1.32x. Okay, and then for this one, it's going to be negative 12.6. And then if you look at the third number, it's a 1. So this is going to stay a 3. Okay, so don't forget your rounding rules that you've been using them for years now. And it's easy to forget some of that stuff. Okay, and then we're going to do the same thing with our second equation. We want to solve that for y. Okay, so when you move the x over, you add it over. So if you add that to both sides, you get 3.2x plus 2. Divide by 6.1. And we'll do the same thing where we're rounding. Okay, so this is 0.52x. And this is going to round up to 0.33. Okay, so now we're going to follow these directions. So we have it in the form. Now we're going to go to y equals. Okay, and in your first y equals, you're going to put 1.32x minus 12.63. So you're putting in this exact equation. All right, so once you have those entered in, we will do the next step together. Okay, the X button is this variable button here. It says xt theta n. The X is the variable for the mode that we're in. So if you press that, that's your variable. Okay, now if you haven't been using this for any other class, you should be in the standard window, but you can also go to Zoom and press 6 for the standard window, which is a 10 by 10 window. Like I said, most of you have that anyway. All right, now, can you see the intersection point on here? No, but you guys would agree that it's intersecting somewhere over here, right? So if I want to see what's more over here, what do I have to adjust? Well, what do I have to, if you zoom in, it's just going to take you further here. Yeah, you can zoom out. So you guys have used the zoom out feature before? Really, if it's over here, don't you need more X values, higher X values? So if you just go to your window, see how my X max is at 10? Let's just set it to 20. The scale is the tick marks. So when you make this higher, just make your scale higher. Like you can go by 2s if you want. And then can I see the intersection? I can. It's really high towards the top. So if you wanted to see further up, you can just go to your Y max. We can make that 20. Okay, and then we have a good window to see where our point of intersection is. Okay, so if you need to see my window again, I just made the max 20 for X, and I made the Y max 20. I did switch the scale, that's not even necessary. Keep it at 1, that's okay, and then you don't have to worry about those. Okay, so now we're going to use the intersect feature. So I'm going to follow what I wrote here. Okay, I'll come and help you in a second. And then we're going to go to second trace. And then I want you to arrow down to the intersect feature. Okay, and then what you're going to do is it's going to ask you first curve, okay? You're going to have to use your arrow. What it's really asking you is where is the intersection on the first line. So you're going to get as close as you can to where you think the intersect is, and you're going to press enter. Then it's going to ask you the same thing for the second curve. You're going to press enter again, and then it's going to ask you to guess. So you end up pressing enter 3 times, and then you should get something that says intersection on there. Okay, so I want you guys to be able to get your intersection there. So you're going to, remember, you go second and then the trace button. You're going to go to your intersect, and then you're going to have to arrow to where your curve is. Once you do that, a lot of times you really just end up pressing enter 3 times, and then your solution is your point. So your solution is 16.2, and then that's exact, so we can't round it to the nearest hundredth. And then the second one we can, so this would be 8.75. And that's your final answer. Okay, so it has to say intersection in order to get that. Okay? All right, and then for the second one, I want you to write down your steps first. And then we'll do that part together. So we guys write down your steps in blue here. So you're going to write the 2 equations. Okay, so when you're solving the equation, okay, the difference is you're going to be writing the two equations, so you won't have to put it in y equals mx plus b form, and then the next two steps are going to be the same. So you're going to be graphing y1 and y2, and then you're going to adjust the window as you need to. Okay, you have to adjust it to see your intersection, and that's using the window. You're going to still use the second trace and then intersection, but now you are not going to be finding a point because you're not solving a system, you're solving the equation. So your answer is only going to be your x value. Okay, your answer is only going to be your x value. Okay, so when you are finding the two equations, they are right here. This is your y1. This is going to be your y2. Okay, this is your y1. This is your y2. Okay, so when you're plugging it in, your y1 is negative 92.21x minus 15. Your y2 is 18x plus 5903. Okay, and then your solution is going to be the x value. So I'm going to help you plug it in, and then I gave you the solution because I want you to see if you can get that value without me. So I want you to be able to check that. So let's plug that into our graphing calculator as our y1 and our y2. And if you want, you can start off with the same window that you had before.
Good afternoon, HHS. Great job with the Spirit Week themes this week. Please keep up the good work. That being said, tomorrow is class color day. Freshmen will be wearing green, sophomores purple, juniors are light blue, and seniors are pink. Student Council is providing colored beads correlated with your class color. If you didn't pick up your beads at the Student Life Fair today, please stop by Miss Littleton's room near the main office to pick your beads up tomorrow morning. And attention staff, you will be wearing orange. Orange beads are provided to you in your mailboxes. Thank you, and go Vikings.
Okay, so what I did is when I saw my original graph, okay, where our x value was to 20, I said, wait, this is intersecting up here. I need to see it. So my window, my y value has to be greater. So I ended up going to 75 and then changing my scale to 5. It just spaces out your tick marks. And then again, you're going to use your intersection feature. So second trace, you're going to go to intersect, and then it's asking you for the first curve. If you lose like your line, you can see this is a negative x. So just keep going the arrow until you see your cursor. There he is. Okay, and then we press enter, 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 and then it's going to give you your intersection. Now this time you're just solving for x, and so your solution is going to be your x value. Okay? Right, and then write down your homework for the day. If you have trouble finding a graphing calculator, there are some online graphing calculators. You will need one, so because you can't use the online graphing one for a test. Okay, and then we'll have to graph paper in your homework. So if you need graph paper, I will put one out here for you.